You gather data from a sample of 6 companies. Based on the table, United Companies spend 15 million of R&D that results to increase in revenue of 6 million. You can watch the other video on how to make scatter plot out from this data. Now let's present the relationship between these two data series by presenting it in a single number. This number is what we call correlation coefficient. We will consider R&D as the variable X or independent variable and revenue growth as variable Y or dependent variable. The formula for correlation coefficient is covariance between X and Y divided by product of standard deviation of X and standard deviation of Y. So there are two important figures, covariance and standard deviation. Let's do manual calculation. Since we use data from a sample and not from population, we will compute sample covariance. The formula for sample covariance is sum of product between deviation of observation from mean of variable X and deviation of observation from mean of variable Y, then divided by and the number of observation minus 1. To ensure that sample covariance is an unbiased estimate of population covariance, here we use n-1 as the denominator. Let's compute deviations of mean of variable X. The average or mean of observation of X is 12, computed as 6 plus 20 plus 15 plus 14 plus 8 plus 9 divided by 6. Its observation will be compared to the mean of 12. So 6 minus 12 is negative 6 and so forth. We will also do the same with variable Y. Average of Y is 4.83 computed as 2 plus 6 plus 6 plus 7 plus 3 plus 5 divided by 6. Observation of 2 minus average of 4.83 equals negative 2.83 and so on. Now, let's multiply the deviation of X to the deviation of Y shown from this portion of formula. Negative 6 as deviation of X is multiplied by negative 2.83 as deviation of Y, which results to 17 as cross product. Now do the same for the rest of the deviation from mean. 8 times 1.17 is 9.33 and so on. Add all the cross product as shown from this part of formula. The sum of cross products is 41. 41 is to be divided by n-1 as shown in this part of formula. There are 6 observations, 1, 2, 3, 4, 5, 6 minus 1. So 41 divided by 5 equals 8.2, which is our sample covariance. Now let's compute the standard deviations of each variable. Standard deviation represented by symbol sigma is computed as sum of square deviations divided by n-1. This part of formula is the variance, so standard deviation is simply the square root of the variance. Let's compute the square deviation of each variable. For variable X, we multiply variation of negative 6 by itself, or negative 6 times negative 6 or negative 6 squared equals 36. Do the same with the rest of the deviation. 8 squared is 64 and so on. The sum of all the square deviation is 138 to be divided by 6 as the n-1. The result is the sample variance of 27.6. The square root of 27.6 is 5.25357, which is the standard deviation of X. Now do the same with variable Y. Y has variance of 3.77 and standard deviation of 1.94079. Finally, we can compute correlation coefficient. Since we already have computed value of covariance of 8.2, standard deviation of X of 5.25357, and standard deviation of Y of 1.94079, the result is 0.8042 correlation coefficient. What we have done before are manual computations. Now let's compute using Excel functions. To compute sample covariance, type the equal sign, then while typing words, it will suggest functions to be used. Choose covariance.s, then open parentheses, then it will ask for array 1. Choose the values of x, then comma, then it will ask for the second array of values. Choose values of y, and then close parentheses. The result is 8.2, same with our manual calculation. For correlation coefficient, type equal sign, then type correl, then open parentheses, then it will ask for first array. Choose the values of x, then comma, then it will ask for the second array of values. Choose the values of y, and then close parentheses. The result is 0.8042, the same with that of manual computation.